Okay, everybody, as I mentioned in the email and the announcement I sent out today, I'm going to have to do a screencast of Management 3603 for today. It's a virtual Wednesday anyway, so I'll have this screencast will be available. You'll be doing it tomorrow, and you'll be able to take a look at the screencast this evening and tonight, etc. So this is in lieu of our live stream class session. Now, we're going to take a look at this case study. We're going to look at cluster analysis. This is from the Foreman text, the text called Data Smart. And yesterday, I went through the textbook. As you recall, there were problems with folks being able to use the software and the VMware in the lab. So I tried to go through the screenshots and discuss some of the conceptual material around what they're doing, and basically how that's all performed using using Excel and walking us through the process. So since you didn't have the benefit of the software, I'm going to walk you through it myself. Now, that all being said, and as I mentioned yesterday, this is probably going to this session will probably last longer than 50 minutes. So if it does, that's okay. Take chunks of it. And before I start, I want to make certain that I have the key for PAR nonlinear. You can upload it. And I have some materials here that are useful, materials on Baroni diagrams and the Wolfram, which is the math website that will talk some more about that. And that'll give you, then I also have an Excel tutorial on the offset function, which is one that we're going to be using. Then a resource on how we select the number of clusters with what's known as silhouette analysis. And then I have some hand notes of my own from the case that will help you in seeing how we did that. There was one final thing, and I forgot to mention this yesterday as a resource, and this is more of kind of a current affairs type of resource. And what it really boils down to is as I mentioned here, the race between the United States and China to develop supercomputers that have such prowess that they can provide us the ability to simulate all kinds of events. And as you've heard me say before throughout this course over and over, we have different types of models. We can build a scale model. We can have an iconic model, if you will. We can build a mathematical model. And the mathematical model gives us the greatest amount of flexibility in trying to see what would be optimal outcomes or a range of outcomes. And so that's the gist there. That's how it relates to this course. Now, we're working in Chapter 2 of the Foreman textbook, and I have it open here where we start with this case, the wholesale wine emporium. And as you recall yesterday, the files are over here in the Foreman files, and I'll go over here and we'll find them. And there's a zip file, so I'm going to you'll want to download those files. I already have them on my desktop, but when you go in, you'll want to download the Foreman files. And I'll just show you here on my desktop. I'm going to open up the zip file, and I'm going to look in Chapter 2, and this is the wine KMC. Okay, so I'm going to make a copy of that and put it out on the desktop. Okay. And you'll want to name it appropriate, like wine KMC, and then add your last name, whatever you choose to do. Let's open up the file. And as we did the setup for this yesterday. This is a company that sells wine, and they're trying to determine if they have clusters of customers. And so they're going to perform a customer analysis based on how customers responded to discounts or special offers that the company had given to their offer to their clients, to their customers, excuse me. So we'll go back up here, and we'll go back over here to the textbook. And this does the setup for us. Then he talks about the initial data set. Okay. And he does, as he mentions, he shows us some spreadsheets. So I'm going to open the file back up here. And the tab there is the offering information tab, or the offer information tab. Let's look at it. Now we have the following data table. We've got the offer number, the campaign, that is what month was a particular offer provided or given, the type of wine, the minimum quantity, the discount percent, the origin of the wine, and is it past peak or not. And this list goes down. He has 30 some odd offers, or 31. So this is a pretty straightforward thing for all intents and purposes. But inside of this data set, we're going to look and see if there are definitive clusters, customers who tend to respond to the same offer. And if they do, then that tells us we have a customer segment. And that means we can tailor our message to them. We can tailor future offers to them. And you've had your intro to marketing course, so you understand how critical and important it is to know your market segments and to understand them. So this coincides back with what's in the book, so I'm going to pop back up there, and he walks us through that. It's 32 offers, I apologize. And we'll go to the next page, and we're going to see a list of the offers taken by each customer, and that's going to be in the Transactions tab right here. So we've started an initial drill down here to say, okay, who responded to what offer? And it's very simplified, where we just simply take their last name, the customer's last name, and the offer number. Okay. Now, this can be accomplished by a couple of things. You could just simply take the data over and in the offer information, and then just translate it over. Copy and paste it. And we're going to turn it into a matrix here, as he mentions. Now, again, the simplest thing to do to get the transactions would be to copy the whole, really, if the simplest to do it would be this. Take the offer information, this tab, okay, right click it and copy it. Then after you've copied it, rename it Transactions, and then just simply get the data that you want. Or you could copy the customer name, and let's see, we've got the offer number, and we're going to get the customer. We're going to have to get the customer last name. So we're going to need to go over here and find the customer last name. And let's see where we have that at. Is the Yeah, we're going to need to go back up here for a second. Here we go. Well, those are the offers. I want to look and see for a second because he has to give us some quick explanation of where he got the customer's last name. And transactions table with the customer. So he talks about using a pivot table. Okay, and he creates a customer's offer. So where I'm probably like with you, I'm taking a look here to say, okay, where in the world did he get the customer names? And this is the base file. He's got these top deals by customer, distances, silhouette. And he's got the top deals by customer. And I want to see where he got the customer names. But he gives us this transaction. I'd had some notes made for myself on where he got the names. And he mentions the transactions tab. Well, this is where we're at. So we're just going to take it on faith that we grab the names and put them with an offer. Now, this is the matrix, and where he has the campaign, all the campaign information, and then he has the names of the customers. Now, what you could simply do would be to copy those customer names and then throw them into, we'll copy them. And then as we look at the transactions, there's a function in Excel that lets us take data that are distributed horizontally and distribute them vertically, as we have here, as he's done here. And let's look at that for just a second. I'm going to look at the formula for that. And I think it's a database function, or look up in reference. We'll take a look here for just a sec. And I think it's going to be a lookup and a reference. And we want to use the transpose is the one. Transpose is the one. We go grab the array, okay, and then we transpose it. So that would be basically how he got it. And I'm going to go over there and grab those cells, and we'll play with this for just a minute. I'm sorry about me whistling in the dark here with you guys. And we're going to go. And it's going to give us the matrix. And we're going to get all of these at H1. This is out of the matrix tab. I don't do that much transposition, so I don't use the function that much, so I'm a little bit dry or rusty on it as well. we'll go ahead and go along here, and we'll stop here. I think it's going to stop at H1, if I'm not mistaken. Pardon me, it's going to stop at DC. So I've got the cells I'm going to transpose. And now, or vice versa. And so I'm going to go back, and I'm going to click OK. And I should have and the transpose should work for me. Well, I'm going to have to look at that one because that's one of those that always drives me crazy when I try to use it. Let's look at it for just a second. I'll waste too much time. And so we're going to get rid of this here for a moment. We know it's H1 to DC1. And I'll go into the bar, and it's going to be the matrix. And I want to get, I think it's going to be C1 to H1. No, it's not the one. Let me go back and get my array squared away. Sorry about that. Sometimes this happens. Not that often, but it does. I'll just escape from that for just a second. Now I'll go back over here to the matrix. Okay, now we're looking at a matrix that runs from it's going to be H1. I'll make a note for myself. Like I said, this could go a little bit long, which it probably will, given this start. And it's going to be H1 all the way over to DC1. Okay. All right, we'll go back in here to the transactions, and I'm going to use the matrix function. And just look up a reference, so I'm going to go transpose. And the array is going to be and that's DC1. All right, and they give us a formula result. Now, one of the things I don't like about transpose is it's a little bit finicky. And sometimes what you have to do is just go ahead and I think if I and go ahead and change these cells, I'm going to change these cells to absolute cell references. And it's giving me some strange stuff about a value. I don't understand that, but trust me, the transpose works. I'll brush up on my transpose. Nonetheless, that's how you would supposedly easily get them. Well, humbled by transpose, what can I say? All right. We might just need to copy those cells and then do the transposition. I'm thinking that's probably going to be the easiest way. Nonetheless, let's get back to the order of business, and I can brush up on my transpose skills. after having made a fool of myself showing it to you and not doing it. Now, here's the list of offers that are taken by the customers. Okay, so you have the offer number and the customer name. As you'll notice, we have customers who took multiple offers. Okay, and as he walks us through that, we talked about that yesterday. The next question is, okay, what do we want to measure? Well, we're going to try to understand the deals that people did not take, okay? And so he provides a binary, he uses a binary approach here where he takes the offers they chose and the ones they did not choose, and that's going to be in this next screenshot and over here in this file now. This is going to be the pivot table of deals versus customers. Here it is. All right. And we want to see the and we want to see for the pivot table how it was put together. And we should be able to see the design on that. And I'll find that here for you in just a moment. This has been a total disaster this morning. But we basically, and I'm inside the matrix there, so I should be able to see the pivot table pop up. And it should show it for me. I want to see if I can get the view of it. There it is, the pivot tables, and I'll look at the design, pardon me, the analyze, and I'll make the field list visible. I'm sorry. There we go. Now we can start to dig into this jewel. All right, as you can look, he's got the customer last name, the offer number, and notice then he has in the columns, he's got the customer. I'm sorry about folks about the putzing around with all of that. And in this pivot table, and then in the rows, he has the offer number, okay? And then he has a count of the offer number. And as I had mentioned yesterday, you can see if you get far enough out, as you move out, you can start to see the clusters very faintly emerge. Now what I'm going to do, I'm going to take this out as much as I can, and I'll illustrate this to you. I'm going to get the whole matrix here, I hope. Okay. And I'm going to use some conditional formatting. And I'm going to highlight the cells, and I'm going to have a rule. If it's greater than okay, well, I'm going to go back up because I want to make sure I've got so many of these blanks. It's going to be simple. I'm going to do the conditional formatting, and I'm going to highlight the cell, and if it's equal to 1, I'm going to make that a yellow fill with green text. Okay? Now you see what I was talking about. I appreciate you bearing along with some of this. But nonetheless, as we get further out, and you can start to see, I'll scroll over, you can see some clusters starting to emerge there. Now, the further you go back from this, the further I magnified away or made it small, I'd see those clusters become more and more definitive. But you could see visually what's going on. Okay? So I'm going to get rid of that stuff, take us back to where we were, and I'm going to go ahead and I'm going to close the field. So we have a lot more we can work with. Now, let me take us all the way over here. And of course, here we are. And here in the textbook now, we've got the pivot table. We have deals versus customers. All right. Now, the next step for us is he wants us to develop a matrix. All right. So we're going to put that and create that matrix on the basis of their purchases. Okay. And so here we are. We have the offer number. And if you're following along in the textbook, you want to check like as I am, you'll see you've got the offer, this is the pivot table. So we'll go to the matrix next. Here it is. And here's the campaign. The type of wine, the quantity, etc. If we want, we can click on the view. To see the pivot table. So we want to get back over to the design view, but it's pretty much given to us here as we look. We've got this whole matrix of everything that everybody purchased. Okay. Now, the narrative in the text, he starts he right below showing us this single matrix. He talks about standardizing our data. All right. And this is to make sure that we detect any outliers and that we're comparing apples to apples or oranges to oranges. We standardize data, we clean them up. And so we're going to standardize each column, as he mentions, by subtracting out the average. Now let's go down here and let's take Adams. Okay. We have the matrix here, right? And they're merged into that single matrix. And then comes the process of standardizing. Now he says we're going to start with 4 clusters. Now, and he talks about standardization at some length there, but we've got our matrix. And again, this will become the basis for us to start to build these measurements. We're going to be using the Euclidean distance, the equation for that, and that's there in the textbook. So we're ready now to go ahead and launch forward. And he says start with 4 clusters. And then here's where he talks about Euclidean distance. And so below this screenshot or print screen of this matrix with the 4 clusters, he shows us how we compute that distance. Now, again, one of the things we do in management science is we try to find a model that works. And if we're wanting to look at clusters, it only makes sense that we would rely on circumference and Euclidean geometry that's the model we would adopt. Okay? So, and there in the textbook, he walks through, he spends a lot of time talking about starting with the 4 clusters. And I would say this, he gives us some steps. We're going to take the matrix and we're going to copy it and then do some work. That's the 4MC. And one of the reasons I included the resource for you in terms of determining the number of clusters, or k-mean clusters, that k is the number of clusters. He gives us a technique for getting that done, and I have a link there also for it to help you determine how many. Okay? So he starts with 4 into 4 groups. And then he walks us through the process of Euclidean distance. And here is that 4MC. So we'll go over and take a look at it. And here's our cluster analysis. And he's in tab 4MC. Now, notice we have a cluster center. And so if we say that we're going to we have four clusters, then we're going to say on a plane like this. Okay, remember using that model from Euclidean geometry, and we're here on a Cartesian plane, right? We're going to say, okay, I'm going to 4, 4 is the middle, is the cluster center for 4, and we have somebody at 8, 2, so we have to compute the distance between them. And he walks us through the process, and there right in the middle of that picture there in the text, we take the square root of the sum of squared distances in each single direction. You say, this looks suspiciously like a standard deviation. Yes, it does. Notice what we're doing here. I'm going to take a minute and talk with you some. Again, in management science, we try to use models, and in this case, we're using the square root. A square root gets data down to their essence. Just the same as if we normalize or standardize data, we produce an essence, something that we can compare one versus the other. We wash the data is what one of my old stat professors used to say. And here we get that the Euclidean distance here is 4.47. And notice that we take that, the difference, okay? And the difference between 8 and 4 is 4, or 4 and 8 is negative 4. And we square it. And then we take the distance between the second, this is the one on the right, okay? So we have the x-axis and the y-axis, and we take the difference between 4 and 2 or 2 and 4. Either way, because we square them, we get a positive number. and then we use the square root, and that's the distance there for that 1 point. At the very bottom of page 43 in the text, he shows us that same formula applied to the matrix. And here's what we have. It's the square root, okay, of the sum of L2 to L33 minus H2 to H33 squared. And he creates a function by using the little curly Q sign. My brain always goes dead on what that sign's name is, but I call it the curly Q thing. It's not a bracket. I'll have to remember. My short-term memory is probably fading me. At this point, you're going, it sounds like it for sure. I understand. Okay? Now, let's go here for a moment and take a look at L2 to L33. Okay? And we'll go here. And let's go here and we find L2, okay, to L33. And we're in the 4MC tab. And so we're going to get the distance for L2, and here we start with atoms, down to L33. Or is it 32? It should be 32. Yeah, it's 30, L33. So he has L2 to L33. I want to see what he's doing there. Oh, okay. He's getting that distance. Yeah, L2 to L33. I'm sorry, folks. I confused the offer number here with the row. Pretty disjointed today. So there's the square root. We use the Euclidean to figure out the distance for atoms to cluster 1. We repeat that process for atoms' distance from cluster 2. Same story from cluster 3. Now you understand why I wanted to take the time to go in depth with this, and I had warned you it would go over 50 minutes. So things have worked themselves out such that I think doing the screencast is better because you're not having to worry about getting your next class and all that. And as I'm speaking forward here, I'll be sending you guys an email about this. I think this is the better way to do this. And tomorrow's a virtual day anyway. And here we are again. And notice that I'm looking at the distance cluster 4. Now I'm going to go back up and take a look at the formula. And notice we start with L2 to L33 minus H2 to H33, and that's for cluster 1. And then as we come into the distance to cluster 2, we're looking at L2 to L33 minus L2 to L33. So we're at H and we were at I. Yikes. Now we'll see J, K, and then we want to get the minimum distance to the cluster. And so we do that. And I'll click inside here so you can see. I use the minimum function. and we get 2.02. Remember the minimum function, the minimum, we get 1.04. Yikes. The assigned cluster is cluster number 2. And I'm going to click on the formula bar for a minute because we're going to use the match function. And I'm going to hit so we can see. In the match function, here's the dialog box. We're going to look up a particular value. In this case, it's L38. We're going to look up an array. In this case, it's L34 to L37. And we're going to use a match type. Now, this is where we want to make certain that we are on top of the match type, okay? And we get the formula result of 2. Now, I'm going to click in match type and it will give us an explanation. The match type, as they say here in the dialog box, is a number 1, 0, or -1 indicating which value to return. Okay? And we can go get some help on this function. And I'll do it real quickly, hopefully. Now, the match type, and this is what I wanted to show you. The default is 1, but let's see the match type behavior. If we use 0, match finds the first value that is exactly equal to the lookup value. Okay? So this also wanted to walk you through this so when you run into something like this, you can reverse engineer it a little bit and get a flavor of what's going on. So we've gone through this process for each of these people, and if we scroll across, we're going to see that for Adams, Allen, etc., we've assigned them a cluster based on Euclidean distance using that formula in a Cartesian plane where we said, okay, cluster 4 is going to be the intersection of x4 and y4. That's our centroid or central point. And then we're going to measure where we're at, and we get that minimum cluster distance, and then we assign them to a cluster based upon an exact match. And I'm going to go back through this match function one more time just to make sure you're here. Here's the lookup value. Here's the lookup array. And then the match type is a number 1, 0, or -1 indicating which value to return. So you have some options. So we went ahead and clicked on help. Okay? And one of the things that Microsoft does now is they'll have a little video for you that plays. And they give us a tip, use match functions instead of one of the lookups. And here's the syntax. And we'll come down to the match type and the match type behavior. If it's a 1 or it's just left omitted, we get the largest value that is less than or equal to the lookup value. Okay? If we use 0, as it says here, match finds the first value that is exactly equal to the lookup value. And then if we have a -1, it finds the smallest value. As they mention here, match returns the position of the matched value within the lookup array, not the value itself. And they explain that. So it's positional, okay? not to be confused with value, but position. That I want to make sure you saw that so you understood a little more fully about what's going on. So we find we've got an assigned cluster for every one of these folks who responded to a deal. And then, as you'll note here, they've used some conditional formatting. I'm going to click on Home, and I'm going to click on Conditional Formatting. And if I'm interested in the rules and how they've been applied, I'm going to click Manage Rules. Okay. And I'm just going to do it in this first one, Cluster 1. Come all the way down here for the set of cells. And there's been a conditional formatting, so I'll click Home. I'm back over there to conditional formatting. And I'm going to click Manage the Rules. There we go. Okay. And it gives us a graded color scale that applies to those set. And that's going to go from green to a red, and we can click on the Edit Rule. So it's basically what's happening here. As you can see, the larger the cluster value, okay, the higher the green. Now, click on Data here, okay, and we'll take a look over here in the textbook. And he shows us the distance between the atoms cluster. Now, you can see the formulas for each of those. Now, on this little jewel, I've got the data analysis. But I don't have, he apparently did not include the solver. So I'm going to click Options, Add-ins, and we've got the Analysis Tool Pack. And power, great. We don't have the solver in here. That's wonderful. Oh, great. Okay. Look, let's see if there's any disabled items. I'll cancel that out. Wonderful. Well, nonetheless, we've figured out here now which cluster each person belongs to, okay? And the next step for us, and he'll walk us through this, is we're going to solve for cluster centers. Now, we assume some, but we're going to solve for them here. And this is where he starts talking about using solver. All right? And we have the equal match. and he has the assigned clusters there that as he shows us in the match. And now we'll go next to solve for the cluster centers. And he talks about that. And he walks them through using the solver. Now, for some reason, solver is disabled on this. And this just makes me crazy. The tool pack, I don't understand why it's not here. So I'll click cancel. Okay. Now, and he shows us using the solver, the parameters. Notice that he's got an objective A36 and to the minimum. And let's go back in here and let's look at A36 for a moment. And here's that sum. So we're looking at the total distances. And so we're trying to find the cluster center. And we get the sum here of L38 to DG38. And that's the assigned clusters. And we get 140.7. Okay? Now, he walks us through running the solver. And again, notice, let's talk about this. The objective is A36 in this file. And we'll just reverse engineer it like that. I do not understand why I don't have the solver in here. This doesn't make me happy. Maybe I'm in the wrong. No, I'm not. And then the changing variable cells, we're going to minimize. The changing variable cells are H2 to K30, H2 to K33. So let's go find H2. And that's this matrix of these values. The solver will generate those. Okay? And we're going to use evolutionary. So far, so good. Been a little bit of a rough patch. Now that he wants us to make some sense of these results, okay? So we have the 4 optimal cluster centers. And as he mentions, look at that distance of 140.7. And we use the conditional formatting to identify those. And one of the things he notes is that they're all NOR and we'll look at the highest value here. A Pinot. And again, here's a Pinot. Actually, this is higher. Cluster 4. and he calls out the deals, and he says he finds they're all Pinot Noir. Deals 24, 26, 17, and 2. Let's look at those. 24. 17. And we have 18 here. And that gives us the 4 optimal cluster centers. And he finds that they're all the same type of wine. And let's see about that. Here's a Pinot. And that's a Malbec, but this is a Pinot. This is a Champagne. And then we've got another Pinot. So we're getting some different results here with this. I think it's primarily because we don't have the solver set there. We didn't run it. Great. Then we get the top deals by cluster. And we just set up a tab to count them. And that's going to be over in the top deals by cluster tab. And he again uses conditional formatting. Then he walks us through the distances. Now this is where we use the offset function. And we look at the distances. And notice again, this is a matrix. We're going to look at Adams versus Allen, Adams versus Anderson, Bailey, Baker, their distances, all right? And we're going to come all the way across over here. And we'll find those for each of these individuals, these folks who respond to these offers, you can see. Now, I have a resource there that talks about the offset function. And as I told you, every time I go through this part of the course, I think it's so valuable for you to see it that I go on the adventure with you. Okay? And I have a resource there that tells you about the offset function. We can square root on here. And it's going to give us that's the square root part. Okay? And you'll want to take a look at that offset function and how it works. And that's how we're getting these distances. Then we use another measure, and this is the silhouette. We've got the top deals by customer. We use some filtering. And he comes up with the Pinot. Then he begins to do the sorting of the clusters. And this is our top deal. And we move on ahead down to the silhouette analysis. And basically, this is how far are your neighbors from you? And what we're doing is we're saying, okay, how tightly compact is a cluster? All right. And number two, how close are these clusters to each other? And then he would create the distance matrix, and he talks about that at great length. And then we see that he shows us a bare bone distances tab and explains it to how he got there. There's the offset. So with the offset, we're able to create vectors and calculate these distances, and then we're ready. We've got the distances tab. And then we're ready to look at the silhouettes. And notice here we get an average of these distances. And this takes each of these customers and their community or their cluster, and it says, okay, if you're in community 2 or cluster 2, how far are you from the people in 1? How far are you from the people in 2? How far are you from the people in 3? How far are you from the people in 4? Who is the closest? Cluster 2. What's the second closest? In your cluster, okay, and this uses the index function. We'll look at that. This is just the array. It just lets us select something using it with an index which we've created, which in this case is going to be C2 to F2, and then the column number. As I said, this is chock full of all kinds of fun references. Excel functions. And then we use a conditional statement to find our neighboring. And we do the logical test if it's true, then we give the value if it's true. If it's false, we give the value if it's false. Then we get the silhouette value. Taking J2 minus I2, and that's divided by the maximum of J2 to I2. So we use a ratio there to get that silhouette value, and then we get the average for all of them. So we're trying to see how tight or diffuse the clusters are. Now this is good for us from a practical standpoint. If you have definitive clusters, but they are diffuse, that is, the clusters are not really tight or really separated from each other, this not only offers you an opportunity to take a look at market segments, it also gives you an opportunity to take a look, well, is there cross-selling cluster to cluster that I might do? Or is there something that's going to be kind of a universal product that I could sell everybody? And then other products become complementary products. As I'd said before, this, I think I said it on Monday, which was yesterday. This book alone, if we just want to really learn about Excel, is an incredible textbook for Excel, because he uses just about every one of these functions in a way it's just so creative. But now we kind of have a figure in terms of the silhouette. Now he walks us through the remainder of this in terms of 5 clusters, and we'll look at the silhouette. Now the silhouette lets us compare our choices. And here we have, if with 5 clusters, we have a silhouette of 0.134. The silhouette for 4 clusters is 0.1492. So there's not that much difference between the two of them. And since there's not, as he discusses in the book, well, we might want to go for 6 clusters if we really want to break this thing down. And this just becomes an iterative process as he shows you in this spreadsheet. I'm sorry about a little bit of the roughness at the start, and what I'm really sorry about is for some strange, bizarre reason, I don't have solver in this file, and this makes me crazy. And I should have the solver add-in. It's not that absolutely critical that we have it. And it may be because it's a compatibility type file. I'm going to try something. I'm going to save this file. And on my desktop, and let's see, I'm going to just go ahead and workbook. I'll replace it, sure. Now, we're going to look at these last tabs. And of course, we've tried the 5 clusters. We've talked about that. Okay? It's just an iterative process. Again, the top deals by clusters. And he walks it through what he calls a more appropriate distance metric. And this is where we're introduced to the Manhattan approach. And you can see. And so these are spherical k-means. And so it's just using a different approach. And that's all that's going on over here. So you can use the Euclidean approach or you can use the Manhattan approach. There's a lot of debate among people about this. Now, because one of them is as the crow flies, as you would say, the other is more realistic. Map makers argue about which one to use all of the time, but he just shows you the alternative. Now, again, we've taken a dive into a really deep ocean, and this is a book well worth keeping because you'll learn more Excel than we could ever teach you. But you'll also see such practical ways he's pulled it together, and we've identified these clusters and how they fit. Now, again, I want to make certain, and I do apologize about 2 things. One, the kind of rough start we had, and number 2 was the craziness with the not having solver work. Frustrating. We're getting some weird stuff. So I'm going to log into Canvas. Go back in. I really don't need to log in back. Just go back over here. And again, for the cluster analysis, all you need to do is upload the wine KMC file, which is over there in the zip files. Okay? As I said, this is probably going to take longer than 50 minutes. I'm going to record this and put it over in the announcements and then send all of you an email telling you that this is for Wednesday. It's a pre-recorded screencast. And I'm doing it for a couple of reasons. Number one, I know it's going to last longer than 50 minutes, and I don't want you to have the anxieties of having to get to another class, and I don't want to run the risk that someone needs to come in and do some work. Also, as usual at this time of year, I start getting called into meetings and so forth, and so I've got one that's just blown me out of the water, and so I got to deal with that one. So to make sure you don't miss it, I go through this, and doubtless you'll have some questions. But if you follow along the text with the file, you'll see. But again, this workshop, and this is really, we could spend several weeks on this and exhaust all of these different functions and how they're used. But I think he provides us a good roadmap for determining clusters. And again, the thing the thing that's most important to understand is that we've used a model, the Euclidean model, to determine clusters. And we've walked through that process using that measure. And again, that's management science, where we try to find something out in the world, some model that works for us, and here we can put it into a mathematical model. Well, folks, I'm going to stop the share and then end the recording. I do apologize again about some of these technical things that are just vexing us. The VMware not working, me not having solver on this file, crazy stuff. And I do appreciate your patience with all of that. And I was very heartened to see the good turnout. This is this book, the Foreman book, Data Smart, is a tremendous, tremendous book and a great look at how we can use big data, because we're going to be working with some. And very creative use of Excel, and a management scientist at heart, because he takes a model and applies it. In this case, it's the Euclidean model for circumference or distance, which lets us look at circumference. It lets us look at clusters. Okay? There's far, far more here. And you'll go and you look at the module, you're going to see, as I had mentioned when we were going through the spreadsheet, the explanation, the offset function. There are also some tools out here that we use for cluster analysis, and then the Easy Excel tutorial on the offset function. And then I have some notes here on distances and silhouettes. And so I think with those resources, you can really dig deep into them. And I'm being upperclassmen, being people who are juniors and seniors, or perhaps all seniors, I'm going to encourage you to do the additional work and really put your teeth into this. Okay? All right, folks, thank you so much. And again, I'll post this. It's going to be a pre-record. I'll send you an email telling you about that, and we'll go from there. Thanks a lot, and I will see all of you Thursday when I'm on campus or next Monday.